Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle. And take that easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is called Wiseacre by Nicholas Duhale, and here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit such that every row, column, and designated 9th cell region contains the digits 1 through 9 exactly once each. In the finished grid, each 2x2 square of cells has to contain at least one even digit and one odd digit. The even digits are obviously 2, 4, 6, and 8, and the odd digits are obviously 1, 3, 5, 7, 9. And this is called the global parity rule. So in every 2x2 box in the grid, there has to be at least one even digit and at least one odd digit. White dots join cells with consecutive digits. Black dots join cells whose digits are in a 1 to 2 ratio, and not all dots are given. So as an example, if this were, say, a 6, this would have to be 5 or 7, because the only digits which are consecutive with 6 are 5 and 7, and these have to be consecutive because there's a white dot between them. If this were, say, a 2, this would have to be 1 or 4 to maintain the 1 to 2 ratio between them, because there's a black dot between them. And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, these digits are in a 1 to 2 ratio. There are only 6 digits which can be next to a black crop key dot. And those are 1, 2, 3, 4, 6, and 8, right? 1 can be in a 1 to 2 ratio with 2. 2 and 4 are in a 1 to 2 ratio. 3 and 6 are in a 1 to 2 ratio. And 4 and 8 are in a 1 to 2 ratio. 5, 7, and 9 can never be next to a black crop key dot, because if they are next to a black crop key dot, well, they can't be, because if you have each of them, you get 2.5, 3.5, 4.5. If you double each of them, you get 10, 14, 18, none of which are digits. So if you have 6 digits in a cell, in a box, which are next to black crop key dots, that means the remainders have to be 5, 7, and 9. So this is 5, 7, and 9, and this is 5, 7, and 9. Well, this is an odd digit, which is consecutive only with even digits. Odd digits can never be consecutive with other odd digits. They are 2 apart. And this has to be 5, 7, and 9 here. Well, what digits? So these ratios have to be specifically in the box. 3 and 6 in a 1 to 2 ratio, obviously. 8 can only be in a 1 to 2 ratio with 4, and 1 can only be in a 1 to 2 ratio with 2. So the thing is, these digits that are consecutive with 5, 7, and 9 can never contain 1 or 2. They have to be 4, 6, or 8 here. These are all even here to be consecutive with an odd digit. Well, that means these can never be 1, 2 as a pair here, which means where is the 1, 2 in the box? They must both be here. And this 1, 2 pair eliminates 1 and 2 with the rest of the column, and that's important because this digit is in a 1 to 2 ratio with 2 unique digits. So therefore, it's the only possible digits that can be the case is 2, which is in a 1 to 2 ratio with 1 and 4, and 4, which is in a 1 to 2 ratio with 2 and 8. Well, since this can't be 2 because of the 1, 2 pair, this must be 4 here, which is in a 1 to 2 ratio with 2 and 8. So all of these are even digits here. Okay. So this has to be 3, 4, 6, or 8. It cannot be 6 here. 3, 4, 8 here, and 3, 4, or 8 here. So one of these digits is guaranteed to be a 3. One of these digits is guaranteed to be a 6, but we don't know which. This is an odd even pair. This must be an odd even pair. So this has to be 5, 7, and 9 again. That's consecutive with 4, 6, or 8 only. We have in row 5. These two are guaranteed to be even because they're consecutive with an odd digit. We have a guaranteed in every white Kropke dot, there's always one odd and one even digit. So this is going to be guaranteed one even and one odd. Same with this, which means we have 4 guaranteed even digits in these 6 cells in row 5. That eliminates even digits in the rest of the row. So this can't be even. These are all odd. Since this is odd, this must be even. So this must be a 1, which makes that a 2 there. These digits are consecutive. One of them has to be 2 because we don't have a 2 available here. And the 2 is not consecutive with the 1 because we already have a 1 in the row. So it's 2 and 3 as one of the sums. The other one is either 4 or it's 8. So it could be a wide variety. Where can the even be in this box 2? Even cannot be any of these digits. We have already 3 even digits in the box. If we had the 4th even digit here, that means we guarantee this 2 by 2 area is all red. Same with even there, that would still guarantee this 2 by 2 area is all red. Same with blues there. So these cannot be blues here. Therefore, these are guaranteed to be red. And we have one guaranteed blue here. Well, we have one guaranteed blue here, one guaranteed blue here. These two are guaranteed blues. So that's all the blues in column 5. So this cannot be blue. This is red, which is consecutive with 2 blue digits. This is blue and red. So one of these is blue, one of these is red. And anytime you have a 1 to 2 ratio, you have to have at least one of the digits is even, right? Because since they're in a 1 to 2 ratio, one of them is going to be double the other. So that means one of these is guaranteed to be even. Well, we have 3 guaranteed evens in row 7 already, so this must be a blue-red pair. So one of these is even, so that means and the other one must be odd, because we already have too many even digits here in row 7. So this also must be odd, which means that's consecutive with an even digit there. So this is either 1, 2, or it's 3, 6 here. Okay. We know we have a 6 here. So the even digit in column 5 for this consecutive pair has to be 8 because we don't have 4, 6, or 2, 4, or 6 available. So therefore, this is consecutive as 7 or 9. We don't know which is which. Therefore, what can this be? This cannot contain an 8 in one of these digits because we have a guaranteed 8 here. So this has to be either 4 with 2, which would force that to be 3, or 4 with 6, which would force this to be 5. Either way, we are guaranteed a 4 here, which means in row 7, where is the 8? 8 has to be one of these digits, which is, again, consecutive with 7 or 9. Okay. Where is 1 in row 7? Can 1 be here? If 1 is here, it's only consecutive with 2, which cannot be here because of 2 in the row. So 1 can't be here, 1 can't be here because that's consecutive with 8. 1 can't be here because this has to be consecutive with 2 other unique digits. 1 can't be here because of that. So this must be a 1-2 pair, which eliminates 1 and 2 in the rest of the row. So this can't be 2. It's 4 and 6, which is consecutive only with 5. That means this can't be 5 here. That leaves us as a 7, 8, 9 triplet, which eliminates 7, 8, 9 in the rest of the row. So this can't be 7, 8, or 9. It's 3, which is only consecutive with 2 or 4. This can't be 2 because of 2 in the row, so that's 4. Therefore, this can't be 4 here. This can't be 4 here. This is a 3, 8 pair, which eliminates 3 and 8 in the rest of the row. This can't be 4 or 8, so that leaves that as a 6, which is only consecutive with 7 here out of 7 or 9. So 7 eliminates 7 here. This is an 8, 9 pair. 3 and 8 eliminate 8 here. So therefore, the even digits in the consecutive digits in row 5 have to be 2 and 8. So we have 2 and 2, it's just consecutive with 3 here. And 8, which can be consecutive with 7 or 9. That means the other odd digits have to be 5 with 7 or 9 there. 3 eliminates 3 here. 7 and 9 eliminates 7 and 9 there. So if this is 8 with 7 or 9, 8 has to be here. So this can't be 8. The remaining digits in row 6 are 1, 5, 7, and 9, which are all odd digits. There we go. We have 3 odd digits here. So this 2x2 box needs an even digit. So this can't be odd, it's even. That means this can't be even, it's odd. So this has to be 2 and 8, which can only be consecutive with 7 or 9. Well, since this can't be 3 here, this can't be 2, this is 8. Which means this cannot be 8 here. It's a 2, 3 pair here. And we have 3 reds in this 2x2 box. So this can't be red. That's blue. This can't be blue then. That must be the 3, which makes that the 2. 2 eliminates 2 here, so it's 1 and 2 there. This is not blue. That's red. This is not red. That's blue. 1 eliminates 1 here. We have 3 reds here in this 2x2 box, so this can't be red, that's blue. So this has to be 4, 6, or 8. 8 eliminates 8 here, so that's 9, which eliminates 9 here, so that's 8. So this is not blue, it's red. This is not red, it's blue. Don't have anything there. These have to be 3, 4, 6, and 8. This can't be 6 because that would force this to be 3, but the global parity disallows that. Nine eliminates 9 here. We have a 1, 5, 7, 9 quadruplet in box 6, which eliminates 1, 5, 7, 9 in the rest of the box. So what does that mean? That means this has to be 2, 3, and 6. This 3 eliminates 3 here, so this is 2 or 6, which is an even digit. That means the remaining digits in row 4 have to be 1, 4, and 8. That means that eliminates 1, 4, and 8 in the rest of the box, so this is 5, 7, 9. 1 eliminates 1 here, so this is guaranteed to be 4 and 8. Well, this can no longer be a 4-8 pair because that would eliminate all possibilities for that cell there. So this has to be 3 and 6, which makes that 3 and that 6. No 3 and 6 here. This is a 4-8 pair. That eliminates 4 and 8 in the rest of the column. So this can't be 4 and 8. That's 1. That eliminates 1 there. So this is 4 and 8. That's an even. This is odd. This is odd. Okay. One of these digits is guaranteed to be even because of the white Kropke dot in between. That gives us 4 even digits in column 2, so this can't be even. That's odd. Two cannot be only be next to 3 here. 3 cannot be next to, can only be next to 2 or 4 here, but that can't be 2 or 4 because of the 2, 4, 8 triplet in the row. So this can't be 3, which makes that an even digit, which makes that an odd digit, and is the 3 here. So this is even digit, which makes this odd, which makes that even. One of these is, we have 3 evens then in column 8. And one of these is guaranteed to be even because you have an even-odd pair in next to white Kropke dots. So this cannot be even, it's odd. So if this is odd, it's 1 or 3, which is in a 1 to 2 ratio with an even digit. So that would be 2 or 6 here. If this is 2, this is guaranteed to be 3, and then this would be 4. If this is 6, this could be 5 or 7. 6 goes 5 down to 4. Or 6, 7, and 8 is there. This can't be 8 because of 8 in the column, though. So therefore, this must be a 4. So this must be 6, 2, 3, 4, or 6, 5, 4 there. Okay. The even digit here has to be 2 or 6. The even digit here has to be 2 or 6. That means the 4 has to be here. That's only consecutive with 5 because we have a 3 in the box there. So this is 4 and 5 there. That eliminates 4 and 5 in the rest of the column. So how do we work this? This is either 2 or 6. If this is 2, this can't be 2, so 2 would have to be there. And there would have to be in a 1 to 2. It would be consecutive only with 1 because we can't have 3 in the column. 6 could be with either 5 or 7. Cannot be 5. So 6 would have to be with 7 here, if that's the case. Well, we have a 7-9 pair in box 6 now, which eliminates 7, 9 in the rest of the box and the rest of the row. So this can't be 7 or 9. It's 5. This can't be 7 or 9. It's 1. This can't be 1 or 7. It's 5. 1 eliminates 1 and 2 as a possibility here. So this is 6, 7 as a pair here, which eliminates 6, 7 in the rest of the column. So this can't be 6, it's 2, which is a 1 to 2 ratio with 1 here. 6, 7 eliminates 7 there, so it's 9, which makes that 7. 5 eliminates 5 here, so that's 3, which is only consecutive with 4 and 2. That leaves that as 6, so this must be a 6, 7 pair here. This must be a 1, 2 pair here. 6 eliminates 6 here, so this is 7 and 6. That's the odd. This is even. We have 3 odd digits here in the 2 by 2 area, so this must be even, which makes this odd there, and that's 2, which makes that 1. This could be either 1. Remaining digits in column 7. We have 5, 8, and 9. Okay. If, okay, this can't be 8 because of 2, 8 pair in the row, so this is odd. 7 eliminates 7 here. Four and 6 cannot be consecutive with 9. So this cannot be 9 here. This is a 5, 7 pair, which eliminates 5 and 7 in the rest of the box. So this can't be 5 or 7. It's 9. That eliminates 9 here. So that's 8, which means this can't be 8 or 9. It's 7. That means this is even. This is odd. 8 eliminates 8 here. So that's 4, which makes that 8. 4 eliminates 4 here. So it's 5 and 4. 5 eliminates 5 here. So it's 9 and 5. So this is odd. This is even. Remaining digits in row 8 are 1 and 3, which are both odd. Remaining digits in, well, we have a 2 by 2 area that has 3 odd digits. So this must be even. That leaves the remaining digit as odd because we have 4 even digits in box 8. So that's 2. This is 9. 2 eliminates 2 here, so that's 8 and 2. 8 eliminates 8 here, so that's 3 and 8. 3 is in a 1 to 2 ratio with 6 only, so that makes this 4. 6 eliminates 6 here, so it's 4 and 6. 4 is only consecutive with 5 out of 5 or 7. So this is 5, that's 7. 3 eliminates 3 here, so it's 1 and 3. This is odd. This is even. Okay, remaining digits in column 4. We have 5 and 9. We have 3 and 6 remaining in column 5. Column 7, we have 1 and 7 remaining. And so 1 eliminates 1 here, so this is 7 and 1. Where is 1 in row 3? 1 can't be here or here because of 1's in the column. 1 can't be here because of 1 in the box, so 1 must be there, and that's odd. Five eliminates 5 there, so it's 7, 9 as a pair. Remaining digits in column 2. We have 4, 5, 7, 8, and 9 possible. 4 and 8 cannot be here because of 4 and 8 in the row. So this is 5, 7, 9, which is an odd digit, which has to be consecutive with an even digit, which is consecutive with an odd digit. So this cannot be 5, 7, or 9. It's 4 or 8. 4 eliminates 4 as a possibility here because of 4 in the row. So that's 8, which means this can't be 8. That's 4 and 8 there. 8 is only consecutive with 7 and 9. So the 7, 9 pair eliminates 7, 9 in the rest of the box. That means this can't be 7, 9, 8. Can't be 4 because it's an odd digit, so this is 5. 5 eliminates 5 here, so it's 9 and 5. 5 and 9 eliminate 5 and 9 in the rest of the row, so that's 8. So no 8 here. This is an even digit, which makes this odd here. Remaining digits in column 3 are 2 and 4. This can't be 4 because of 4 in the row, so this is 2. That's 4, both of which are even digits. Okay. 5 eliminates 5 here, so it's 9 and 5. 9 eliminates 9 here, so it's 7, which makes that 9. 7 eliminates 7 here, so that's 9 and 7. 7 eliminates 7 here, so it's 6 and 7. 6 eliminates 6 here, so it's 3 and 6. Therefore, this is odd. This is even. This is even. That's odd. Well, that gives us one more even in row 3 and one more odd in row 1. That leaves that as a 3, that as a 6, and that's a solution. Fairly straightforward. Yeah, some interesting logic there throughout. Some pretty big restrictions with the Kropke dots and the global parity. And the white Kropke dots too, yeah, so. But the black dots were really the break-in, obviously. So. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.